Imagine placing a bowling ball on a trampoline. The fabric bends. Now imagine replacing that bowling ball with something so unbelievably heavy. The trampoline tears. That's the closest picture we have to a black hole. But here's the strange part. A black hole isn't a giant vacuum cleaner. It doesn't roam through space, sucking everything into it. In fact, if our sun magically became a black hole today, Earth would keep orbiting exactly the same way. Only, everything would become very cold. So, what actually is a black hole? It starts with a massive star, much bigger than our sun. For millions of years, that star fights gravity. Gravity tries to crush it inward. The star pushes outward. It's a perfect balance until the fuel runs out. The star suddenly loses the fight. Gravity wins. The entire star collapses. In seconds, imagine squeezing Mount Everest into something smaller than a grain of sand. That's the kind of compression we're talking about. The result is a black hole. But here's where things get weird. A black hole isn't really a hole. It's a place where so much mass is packed together that gravity becomes almost impossible to escape. Even light, the fastest thing in the universe, can't get away. That's why it looks completely black. Around every black hole, there's an invisible boundary. Scientists call it the event horizon. Think of it like the point of no return. Cross it, and nothing comes back. Not spaceships, not radio signals, not even light. Which raises an unsettling question. What would happen if you accidentally fell in? At first, nothing. You wouldn't suddenly hit a wall. You wouldn't notice crossing the event horizon. But something strange would happen. Someone watching from far away would never actually see you fall inside. To them, you would appear to slow down. More and more, until you seemed frozen in place. Eventually, you would simply fade away. Time itself is slowing down near the black hole, but from your perspective, everything feels normal. Until gravity becomes stronger at your feet than at your head. You begin stretching longer and longer. Scientists have an oddly funny name for this, spaghettification, because your body would eventually resemble a strand of spaghetti. Thankfully, this would happen long before you reach the center of most small black holes. But then comes the biggest mystery of all. What's actually inside? The truth is, nobody knows. Our best equations stop working. Physics breaks. Some scientists think everything is crushed into an infinitely tiny point. Others think black holes may connect to other parts of the universe. Some even wonder if they could hide entirely new laws of physics. And then, there's one final surprise. Black holes don't live forever. In 1974, Stephen Hawking discovered something shocking. Black holes slowly leak tiny amounts of energy over trillions upon trillions upon trillions of years. They evaporate. One day, even the largest black hole in the universe will disappear. Completely. It's one of the strangest ideas in science. The darkest objects in existence aren't eternal. They simply take longer to die than almost anything else. Black holes may look like monsters hiding in space, but they're also giant laboratories. Places where gravity, time, and reality itself stop behaving the way we expect. And every time scientists learn something new about them, they uncover an even bigger mystery. Because the most fascinating thing about black holes isn't what we know. It's how much we still don't.